Okay, here we go. It's Pre-Algebra B, Unit 5, our last unit, and this is how I would solve the practice test. I'm going to go through all 20 questions. I have something to write with, something to write on that I can keep for the test, and I have a calculator. I recommend you have all those as well. And let me get my pen working. Whoops, I turned my little right pad off. See if I can, there we go. There's the pen. I like the color. And here we go. You and two friends, Adam and Elena, will only play a game if it's fair for all three of you. The game your friend proposed will roll 2 dice and find the sum. If the sum is from 1 to 5, you get a point. 6 to 7, Adam gets a point, and 8 to 12, Elena gets a point. Is the game fair for all three of you? Well, I know you're not going to roll a number 1, so the first person gets the numbers 2, 3, 4, and 5. Adam gets the sums 6 and 7, and Elena gets the numbers 8, 9, 10, 11, and 12. And I know you can roll 1, 1. If both dies are a 1, you can roll 1, 2. Because if both dies have to be a 1, then you can roll 1, 12. To get a 3, one die has to be a 1 and the other one has to be a 2. So you can get it two ways, with one die a 1 and one die a 2, and the other way would be the other die a 1 and the other die a 2. So there's two ways to get a 2. So there must be two ways to get an 11. And then with a 4, they could both be 2s, or one could be a 1 and the other a 3, or one could be a 3 and the other a 1. So there are 3 ways to get a 4, which means there must be 3 ways to get a 10, and 3 ways to get a 4, and a 5. You have a 1 and a 4, a 2 and a 3, a 3 and a 2, and a 4 and a 1. So there's 4 ways to roll a 5 with 2 dice, just like there's 4 ways to roll a 9. And so it's clearly not fair for me because I've got a total of, there are 1, 2, 3, well there's 10 different rolls I could do and I would get a point. Where this person, 1, 2, 3, that's a 4. And there's going for 8, you could roll 4, 4, 5, 3, 3, 5, 2, 6, or 6, 2. So 5 ways, 5 to roll that. And then a 7, you could roll a 1 and a 6, a 2 and a 5, 3, 3, 4 and a 3, 5 and a 2, and 6 and a 1. So there are 6 ways. So this person would have 11 options, 11 possible rolls. This person would have 15. So this person would have the most. This person would have 11. I'd only have 10. So no, the game is not fair. Who has the biggest advantage? Elena. She has a total of 15 different rolls that will score her a point. Okay, a bag contains 5 yellow marbles, 9 red, 3 blue, 6 white, and 7 black. What is the probability of pulling a red marble out? So red, probability is going to be favorable outcomes, what you want, favorable outcomes over total outcomes. So favorable outcomes, we want a red one. There are 9 red. Over total, how many marbles are there? Well, let's add them up. 5 and 9 is 14, and 3 is 17. 17 and 6 is 23, and 7 is 30. So the likelihood is 9 in 30. And that's not an out, but I can simplify this. 3 goes into 9 3 times. 3 goes into 30 10 times. So there's my answer, the second one, 3/10. All right, evaluate 6 permeation 5. So the formula for permeations, let's remember this. It's the total, that's 6 factorial over the total minus the spots factorial. So that'll equal 6 factorial over 5 factorial. And 6 factorial is just 6 times 5 times 4 times 3 times 2 times 1 over 5 factorial. 5 times 4 times 3 times 2 times 1. So we can just cancel all these out. So the 5 factorial on the bottom would cancel out with the 5, 4, 3, 2, 1 on the top. And it'll just leave us with 6. So evaluating that, I get the answer 6. And that's a permutation. Different from a combination. Permutation spots matter. Combination, it doesn't matter the order or the position. Like a combination pizza. It doesn't matter if they put the pepperoni on first, second, or third. That's if you had a 3-item combination. And it's almost lunchtime here, so I'm getting a little hungry. Find the probability of A or B. Probability A or means we add. When you see or in a probability, we add. So it's probability of A plus the probability of B. Probability of A is 11 over 25. Or we add, you should write that down in your notes somewhere, probability of B. Ah, great. We got common denominators. So just add the numerators. 20 over 25. I don't see that answer, so I'm going to reduce. 5 goes into 20 4 times. 5 goes into 5. 5 goes into 5 times. 5 goes into 25 5 times. Okay, what are the odds? Odds are a little different than probability. Odds are favorable outcomes over non-favorable outcomes. What you don't want. That's how odds are different than probability. Odds are non-favorable outcomes in the denominator, not total outcomes. So, spinning green, there's 1 green. How many not green? 1, 2, 3, 4, 5. That's how odds differ. The odds are 1 in 5. The probability is 1 in 6. So probability here would be 1 in 6. The odds are 1 in 5. That's how they differ. Okay, on to my next set. We've got to go. We've got to do 20 of these, but we moved through the first 6 pretty fast. My computer's taking a little break. Ooh, I just went a little too high off the screen. There you go. You toss a coin, and it lands tails up. Whoa, didn't expect that. I don't know what happened there. Okay, let me try this again. You toss a coin, it lands tails side up. You roll a number cube, and it lands on 4. Are the events independent or dependent? Does doing one have any effect on doing the other? No, they're independent. Flipping a coin has no effect on the outcome of rolling a cube, and vice versa. So these are independent. I-N-D. That's where I'm stopping. Okay, you roll a die 50 times, and the results are shown on the table below. Number one, oh, this is, so I rolled a 1 4 times, I rolled a 2 9 times, a 3 6 times, a 4 12 times, a 5. Okay, what is the experimental? So that's based on the actual results. That's how experimental differs from theoretical. Theoretical, they should all be the same. Experimental, this means I went and I actually did it. So what is the probability, theoretical or experimental probability of rolling a 5? Well, we go right here. And they rolled that 9 times out of 50. Remember, favorable outcomes, they want to know about rolling a 5. And they did it, how many times did you do it? 50 times. So 9 over 50. Last answer choice. Okay, this is right at the bottom of your page. You roll a number cube, roll a number less than 3. Okay. If I roll a number less than 3, so I could roll a 2 or a 1. Event 3, roll a prime number. Are the events disjointed or overlapping? Well, they're overlapping because a 2 is less than 3, and 2 is also is prime. 2 is prime. And so a 2 could be in both my groups. It's in event A, it's part of event A, and it's part of event B. So that is overlapping. Okay, evaluate. Now we have a combination. So the combination formula is a little different than the permutation. Combination is the total number of elements over the spots available, factorial, and then the rest of the permutation formula. 7 minus 3 factorial. So we would end up with 7 factorial over 3 factorial times 4 factorial. And so we know 4 factorial is 4 times 3 times 2 times 1, and 7 factorial actually is 7 times 6 times 5 times 4 factorial. I'll stop there. And this is 3 factorial over 4 factorial. So I'm just going to cancel out my 2 4 factorials. Now I got 7 over 6, or 7 times 6 times 5 times 3 factorial, which is the same as 3 times 2. So I could do all this math. I could go 7 times 6 times 5. And let's see, that's the same as 7 times 30, or 210. And this is 6, so 210 over 6. 3 times 2. Well, I could do times 1. But it's still 6, so I get 210 over 6. But another thing I could do, I could simplify this. I could go 3 goes into 3 one time, 3 goes into 6 2, and then 2 goes into 2 one time, 2 goes into 2 one time. And now I have 35 over 1, which is the same as 310 over 6. And 35 over 1 happens to be the number 35. So that's how I would do that. What is the probability of flipping a coin and it coming up heads 4 times in a row? Well, it's the probability of it happening, and this is an and. Comes up once and twice and 3 times and 4 times, and when we do probability of ands, we multiply the individual probabilities. So the probability of flipping a coin and it coming up heads once is 1/2, right? 1 head, 2 options. So once, there's twice. So do it once, it's 50-50 or 1/2. Do it twice, it's 4. Do it 3 times to get heads and heads and heads. That'll only happen 1 every 8 times, because 2 times 2 times 2 is 8. To get heads, 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 and heads 4 times in a row, that'll only happen, theoretically, once every 16 times. So there you have it. And we've got 9 to go, I believe. Winding down here. Semester's almost done. 9 more. One last video. There we go. We got 12, 13, and 14 on the screen. You randomly draw a marble from a bag. You don't put it back before drawing a second marble. Are these events are events? Boy, something happened with this. I'll just say true. They're dependent. They're dependent because the second draw is affected by the first draw. So they are dependent because you didn't return whatever you took out. Okay, that was an easy one. There are 10 sprinters competing for first, second, and third place ribbons. How many different ways can the ribbons be awarded? So place matters because you can come in first, second, or third. Place matters, so it's a permutation, and total of 10, and there's 3 spots, so 10p3. Our permutation formula is going to be 10 factorial over 10 minus 3 factorial. You got to do the 10 minus 3 first. So it's going to be, that tells me it's 10 factorial over 7 factorial. So I'm just going to rewrite that. I'm going to cancel out the 2 7 factorials, and this, so on the top we're just left with 10 times 9 times 8. We took the 7 factorial and canceled it out with this 7 factorial. So 10 times 8 is 72 times 10 is 720. And 20 boys are trying out for 10 spots on the basketball team. If you wanted to a determination of how many different groups of 10 can be created, you use permutations or combinations. And I would just use combinations because there's 5 spots. And order doesn't matter. You're either on the team or you're not. So I'm using combinations. If there were spots, then it'd be a different story. Okay, now we're going to do 15 and 16, but first I'll do 15. What are the odds of rolling 2 number cubes and getting the sum of 8? Well, first, how many outcomes can we have? We could have 4 and 4. We could have a 3 on dice 1 and a 5 on dice 2. We could have a 5 on dice 1 and a 3 on dice 2. This is kind of like that first problem we did. Or we could have a 2 on dice 1 and a 6 on dice 2. Or a 6 on dice 1 and a 2 on dice 2. And those are the only combinations. There's 5. Total outcomes, there's 5. Total out. What are the odds of rolling 2 number cubes and getting the sum of 8? Well, how many possible outcomes are there when you roll 2 dice together? Use your multiplication rule. There's 6 on the one die and 6 on the other. Your multiplication rule says take the number of options on one and multiply it by the number of options on 2. So that's the multiplication rule. It's going to tell us there's 36 possible outcomes. Right now my computer's taking a break. There it is. So 5 over 36. And if you think back, remember we said there's one way to roll a 2 with 2 dice, and then it went up and down. If you added all those together, you would end up with 36. Okay, number 16. You are required to choose 2 topics from a list of 6 and write about on your science test. How many possibilities. Again, this is a combination because it doesn't matter which one you write it first or second. So it's combination 6, 2. And the combination formula will be 6 factorial over 2 factorial times 6 minus 2 factorial, which will equal 6 factorial over 2 factorial times 4 factorial. And I'll cancel this 4 factorial, I always cancel the biggest one out, with the 4 factorial up here, which would leave 6 times 5. And the 4 factorial is gone with this 4 factorial. 6 times 5 over 2 times 1, which is the same as 2. And 2 goes into 2 one time. 2 goes into 6 3 times. So I get 3 times 5 over 1, or 15 over 1, which is just 15. 15 possible pairings. And guess what? We are down to our last number 17, number 18, number 19, and number 20. Dun, 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 dun. 17. Whoops, that's a little too high, I think. There, that's better. I wonder what that is for. Danger. Okay, there are 6 black socks, 6 blue socks, 12 white socks, and 4 patterned socks in a drawer. What's the probability of pulling a blue sock, replacing it, and then drawing a patterned sock from the drawer? So this is an and, because it's the probability of drawing a blue sock and then drawing a patterned sock. So and when you have ands, you add. No, you don't. You multiply. Ands, you multiply. Ors, you add. Okay. So probability of drawing a blue sock. There's 6 of them. How many socks do we have? 6 and 6 and 12. 6 and 6 is 12, and 12 is 24. 24 and 4 is 28. So I got 28. 6 over 28, that's not an answer choice. So let's simplify. 3 over 14. That's not an answer choice. Oh, I'm not done yet. Because then I'm going to take that and multiply it by drawing a pattern sock. I put that sock back. Didn't say drawer, probably replacing it. Yeah, I replaced it. I put it back. So then will be 4 over 28, which can be simplified to 4 goes into 4 one time. 4 goes into 28 7 there. So now I'm going to do that math. And I get 3 over 4 times 7, or 14 times, I don't know. 4 times 7 is 28, carry a 2. 7 times 1 is 7 plus 2, 98. 3 over 98. It's not very likely, but it could happen. Couldn't happen in my sock drawer. Okay, find the probability A or B. It's an or. We add. Or add. Okay, if they're overlapping. Find the probability if events A and B are overlapping. So what you have to do, it's probability of A plus, it's or, probability of B, and then we got to subtract out the overlapping part. Subtract out the overlap. So 9, when they're all common denominators, so we just add the numerators. So 9 and 5 is 14, minus 3 is 11. You should come up with 11 over 18. And then what's tricky about this, it's an or, so we're just adding, but with the overlap, you always got to subtract out the overlap. Okay, our final 2 before we go to the exam. The numbers 1 through 10 are recorded on individual slips of paper and placed in a hat. What's the probability of drawing a 3, not replacing it, and then drawing a 7? So it's an and, so we multiply. And we start out drawing a 3. There's 1 3 in the hat out of 10. And we don't replace it, drawing a 7. There's 1 7, but there's only 9 pieces of paper in there now. So 1 in 90. 1 in 90 is what I got. Hopefully that's what you guys got as well. My last problem, if you roll 2 number cubes, what's the probability of their sum being 9 or higher? Oh my gosh. So let's do 9. How many 9s are there again? I forget. So there can be a 3 and a 6, 4 and a 5, 5 and a 4, and a 6 and a 3. So this is the one die, and this is the other. So there's 4 possible ways of getting a 9. That means there's 3 possibilities of getting a 10, 2 possibilities of getting an 11, and to get a 12, they both have to be 6s. So how many total is that? That's 10. There's 10 ways to get a 9 or higher. What's the probability of their sum being 9 or higher? 10. And how many is their total? I told you we use the multiplication rule. One die has 6, the other die has 6. Multiplication rule says if you want to find out the total possible options, you multiply them. So 10 over 36. I'll simplify that. 2 goes into 10 5 times. 2 goes into 36 18. So the probability is 5 over 18. All right, thank you very much. Last video semester. And now I just need to stop it. Maybe.